All right, now in section 8.2, we are still calculating confidence intervals for a single population mean, but we're going to do it using a new distribution called the student's t-distribution. And the student's t-distribution comes into play when the population standard deviation is unknown. And just like, the previous section with confidence intervals, we needed to calculate uh, the margin of error or the error bound for the mean. And now we're using a little subscript t to represent this as the error bound calculated using a student's t-distribution. And we're going to be also calculating sample size using the student's t as well. So let's, for context, look at the formula that we used in the previous section. So this is when we calculated the margin of error, or the error bound for the mean, using the normal distribution. And we had a z alpha 2 score. So this was the critical value of a normal distribution. And the reason why it was because alpha divided by 2 is because the alpha, which represents the significance level, got split in half and put on either side of the distribution in the tails of the distribution. And we used that area in the tails to calculate our z critical value. And since the population standard deviation was known, we could use it, in the formula right here. And then it was over the square root of n. Now look at this equation. Okay, so look at this equation from last section and compare it to the margin of error equation in this section. So previously, the population standard deviation was known, but now we're looking at the scenario where the population standard deviation is unknown. So, what do? If you don't have the population standard deviation, you use the next best thing. You use the sample standard deviation. And when you have the population standard deviation being unknown, now you can't use the normal distribution anymore. And now you use the student's t-distribution, and you're going to be calculating a t critical value or a t alpha 2 critical value score. And with just those changes, you'll then use, the same similar formula to calculate error and create a confidence interval. All right, we'll get into the student's t-distribution next. But what I want to do is I just want to connect, what we did in the previous section, with what we're doing in this section, 8.2. And, in 8.2, this is the scenario that we're looking at. And these are the changes that are coming because of the population standard deviation being unknown. All right, so let's stop here.